This is another very common trig application, the Ferris wheel problem. So this one's a Ferris wheel, has a radius of 20 meters. It rotates once every 40 seconds. Passengers get on the wheel at the lowest point, which is 1 meter above the ground. Suppose you get on the wheel and it starts to rotate. So first thing I'm going to do is I'm going to try and get a sketch of what's going on. So I'm actually going to just draw on top of this Ferris wheel here just to show everything. So the radius of the wheel is 20 meters. So that's middle to the top, middle to the bottom. And then the bottom is actually 1 meter off the ground. Then I can set up my axes and I'm going to put in the low, the middle, and the high. The low is where you get on, which is 1 meter above the ground. And then the middle is the radius plus the low, so that's 21. And then up to the top is another 20, so 21 plus 20 is 41. Now I can go, I know I start at the bottom, and it's going to go all the way up to the top, and all the way back down to the bottom is 1 revolution, and that's 40 seconds. The middle is the vertical displacement, which is 21. And the amplitude is just the radius, so middle to the top is 20, but it's always the radius is always your amplitude. Here we're going to do two different equations. I could have a phase shift of 20 to the right, or I could also make this a negative cosine curve, because if you look at what's graphed, that's actually just a cosine curve upside down. So I could make a negative cosine curve with no phase shift. So first equation, if we just do a normal positive cosine curve, the amplitude's 20 cos, and then it's 2 pi over 40, t minus 20 to go 20 to the right, plus 21. I could also write this as h equals negative 20, so it's now an upside down cosine curve, cos pi over 20, so I'm just reducing that 2 pi over 40 down to pi over 20, t, because there's no phase shift, so it's just t, and then plus 21. You do not need to find both of these solutions, but it's just worthwhile knowing that negative solution because it's a little easier to work with when we have to answer parts C and D. So it's easier to plug numbers in to the second one, and it's easier to put it into Desmos as well. But that's basically what we're going to do. So for part C, we need to find the height above the ground after 45 seconds. So I know that's t equals 45, and we're just going to plug that in. So I'm going to use the second equation, and all we're really doing is h equals negative 20 cos pi over 20 times 45 plus 21. So you can just plug that into your calculator and get the solution, or we can also plug that into Desmos, which is another way of doing it. So I'm just plugging the equation into Desmos, and then I'm going to solve it. The benefit of Desmos is I know in part D I'm going to have to use Desmos, so sooner or later. So t is x in this case, so I just put x equals 45 and find that intersection, and we get 6.86 meters. For part D, h equals 35 meters, so I'm just going to graph y equals 35 on Desmos, and I'm going to find solutions on the first cycle, so on that first up and down. So I got 14.9 and 25.1 from Desmos. And then remember, if you find your answers for one cycle, you can always use the period to find the answers on the next cycle. So I just got to add the period, which is 40 seconds, on to each of these answers to get answers on the next cycle, and you can just keep on going forever. So 14.9 plus 40 is 54.9, 25.1 plus 40 is 65.1. If you need more solutions, just add 40 to those two answers.